So I'm going to go on and talk about some work we did to improve on that map that I spoke about. So in 1999, Steve Warren made a map of snow depth using all these observations from Soviet drifting stations, and that involved a lot of averaging. And it basically made a map for every month of the snow depth and the snow density, and we use that in satellite altimetry-based retrievals of sea ice thickness. So the role of snow, at least in radar altimetry, is that it hides sea ice. It hides sea ice in two ways. One of them is it weighs the sea ice down and presses it under the water, so that only a little bit of the ice pokes up above the water because it's weighed down, and it belies a huge chunk of ice that's lying below the water. And another more nuanced way that snow hides sea ice is that it slows down the radar pulses. It slows the speed at which they get to the ice. So it makes it seem like the ice is further away when you process the radar pulses and you see the timing of the return. If snow didn't exist, sea ice thickness estimation with radar altimeters would be relatively simple and relatively certain. We just bounce some radar off the ice, bounce it off the ocean, and look at the time difference in when the two respective pulses get back to the receiver. And we could, using the speed of light, just convert that time difference to how far the ice is poking out of the water. And if we know how far the ice is poking out of the water, we can estimate how much ice is actually hiding below the water. But it gets much more complicated when snow covers the sea ice, because suddenly the snow is slowing down our radar waves, hiding sea ice like that, and it's also pressing the ice flow under the water. So even though there's just a little bit of ice poking out of the water, there could be potentially quite a lot under the water. So snow is really, really important. It's a really important part of our sea ice thickness estimates. And if you process the same data twice, once with snow and once without snow, the data with snow leads you to much, much thicker sea ice. So we've got good reason to be concerned about the veracity of these maps. We really need the maps to be right. And ideally, we don't want maps. We want interannually varying maps of snow depth and not just fixed ones for the whole time. So that's kind of a summary of what I've just said. As well as the interannual variability in these snow maps, we'd also like to know if snow is declining. I showed you that time series earlier of the stake measurements, and you could sort of almost visually see the decline in snow depth. And we do know that from both these measurements and Operation Icebridge measurements over several years that at least in the Western Arctic, that the snow depth is declining. That's particularly the case over first year ice, over seasonal ice, because it tends to freeze up later in the year, which means that snow just falls into open water for longer, and snow has less time to accumulate on sea ice. So snow cover is declining, but most of the altimetry community, certainly the radar altimetry community, is still using the same maps every year that were generated in 1999. So what we did for some of the work that I did in the first half of my PhD is we replaced these snow maps with data from a model. We did quite a lot of evaluation of the model to check it was roughly doing the right thing. And we found that because this model incorporates interannual variability in snow depth, and also includes trends in snow depth because it accounts for this later freeze up of the ice, that's one reason. We saw much faster decline in sea ice thickness, and we also saw much higher variability in sea ice thickness over the 2002 to 2018 period. So here's a graph that's got some rather cryptic letters on it. The blue is the modified Warren climatology, that's the map. And the red is snow model LG, with LG standing for Lagrangian. That's the model we used. So you can see that it turns out the red line, when we calculate it with this exciting dynamic snow data that has trends and variability, the sea ice thickness that you calculate for all of the coastal seas in February is much more variable every year, and it's trending at about twice the rate. In fact, in February, it's got a downward trend of more than twice the rate. So that's a significant revision, whatever way you look at it. And you might doubt that the trends in the model output are correct. You might doubt the magnitude, and you might also doubt the variability. But the key finding is that there are trends and there are variability, both in the observational data and in the models. So we know at least for a sign, plus or minus, that the trends are steeper and the variability is greater than was previously calculated. And we could only do that calculation from 2002 in the marginal seas. So that's all of the areas I've shaded on the left, apart from the central Arctic, because that's basically the latitudinal limit of the satellite that operated between 2002 and 2010. But these are really important seas, actually. When I started doing the work, I was a bit annoyed that I had to only analyze these marginal seas. I think that the term marginal always sounds a bit derisory. But it turns out these seas, particularly the Kara and the Laptev and the East Siberian, they're totally critical for shipping between Europe and Siberia, Europe and places like Korea, it's shown on this map, but also China and Taiwan and Japan. And you can really save a lot of carbon and save a lot of time by shipping through the Arctic. But when you do that, you're really, really sensitive to the sea ice thickness in these marginal seas. In the summer, the ice is increasingly retreating to the central Arctic, but in the winter, which is when we can measure the sea ice thickness anyway, in thin ice years, you can push an icebreaker through, and you can push a ship through full of goods. But in really cold, thick sea ice winters, you just can't do that. And actually, right now, there are ships being rescued in the Laptev Sea. There are 2 ships being rescued because they just got it wrong. They just got the sea ice thickness wrong. They particularly got the timing of the winter freeze up wrong, and they're stuck in the ice. So these marginal seas, the variability and the trends in sea ice thickness is really key to a lot of people, not just scientists, but also economists and everyone that buys stuff from China, which in Britain is almost everyone. So one interesting thing, just as an addendum, is that even though the distance is only sort of 25% to 37% shorter by shipping through these marginal seas of the Arctic Ocean, you basically halve the time it takes. And that's because you don't have to go through the Suez Canal, which we saw getting blocked earlier in the year by a ship that sort of went sideways. So the Russians know this. The Russians, it's their exclusive economic zone, and sometimes it's in fact in their waters. It's less than 7 miles when you sail through the islands in the Kara Sea. So being able to accurately characterize the sea ice thickness trends in this region requires a snow product with good trends and good variability. So we sort of inadvertently found that research had some real world application, which was quite pleasing. And I don't want to brag, but the vice president of Russia actually about a month ago, I'm not saying he read my paper, but he might have done, actually gave a press conference about this exact issue and how they're right now aiming for year-round winter shipping via the Northern Sea route, via the Northeast Passage, as some people call it. That was on October the 11th, and we've seen these ships getting stuck just a few days ago in the Kara Sea. So the headline here shows that the trends really do matter, and climate change is happening literally right now, and people are adapting to it. It's not something in the future. But it also shows that the less glamorous statistic, the variability, also really, really matters to people that actually use the Arctic. And that's where accurate snow data can come in. So that's my final slide. If anyone's got any questions or wants to discuss either of these little mini talks on the Soviet drifting stations or the sea ice thickness stuff, then do speak up, and thanks for listening.